Good morning, everyone. My name is Doug Korver, and I'm a poultry nutritionist at the University of Alberta, and I'd like to spend a little bit of time talking to you about the Poultry Nutrition Research Program at the University of Alberta. So I received my PhD in nutrition from the University of California, Davis, and I've been at the University of Alberta since 1997. I teach a number of undergraduate nutrition classes and also graduate level nutrition classes in metabolism. And outside of my teaching and research responsibilities, I'm also a member of the National Academies of Science, Engineering, and Medicine Committee to revise the 1994 NRC nutrient requirements of poultry. So we're hoping that will be completed by next year, and we'll have some updated information that will be relevant to industry and researchers. And in my free time, I enjoy bird watching. I travel a lot for my job, and so I like to take an opportunity to see the countryside and go bird watching when I travel. Of course, the research program is dependent on graduate students, and so I want to briefly introduce you to my graduate student team. Teresa Cheng is a master's student. She'll be presenting on Monday morning. Nella Batras is also a master's student, and she'll be presenting Tuesday. This is some work that she did as part of an independent study project with Val Carney. Emmanuel Egois is a PhD student, and she'll be presenting both today and on Wednesday. Edward Fan is a PhD candidate, and he'll be speaking on Wednesday morning. I have also a new PhD student, Matt Orishak, who will be working on faba beans. His project has yet to get started, and so he won't be presenting this morning. And Mauricio Sanabria is a master's student. He is finishing up, but he is working in Colombia in the poultry industry. So the background for my research in broiler gut health and antibiotic alternatives really is in the area of needing to find suitable replacements for antibiotic growth motors in the poultry industry, particularly in the broiler industry and also the turkey industry. Now, we know that necrotic enteritis is one of the biggest challenges with removing antibiotic growth motors from poultry diets. And we know that coccidiosis is a common predisposing factor. And so my group has developed a subclinical natural necrotic enteritis challenge model. And we think this is important because the typical clinical challenge models involve basically giving the birds a dose of Clostridium perfringens that makes them clinically ill. Now, of course, we've learned a lot of important things about necrotic enteritis through that, but we want to really work in the space that prophylactic antibiotics, antibiotic growth motors also work. So antibiotic growth motors really work from preventing clinical disease or reducing the impact of systemic disease rather than being used to treat clinical disease. And so when we're evaluating potential alternatives to antibiotics, we want to make sure that we're in that same space. And so we give the birds a 15 times coccidiosis vaccine challenge at day 12, followed by a 24-hour feed withdrawal at 18 days of age. And that creates some chaos in the intestinal tract. Clostridium perfringens is an opportunistic pathogen, and this chaos in the digestive tract creates that opportunity where it can gain a foothold and also cause some subclinical disease. So we typically look at lesion scores at day 21 or day 22, and we monitor performance before, during, and after the challenge as well. And we can look at systemic markers of inflammation like acute phase proteins or pro-inflammatory cytokines. We look at gut microflora and so on. There's a number of different ways that we can assess the impact of this subclinical challenge, and then also the ability of these alternatives to antibiotics to replicate or to achieve the same degree of protection as we see with growth-promoting antibiotics. Now, as I mentioned, a number of my students are going to be giving presentations, and so I don't want to steal their thunder. I will just give an overview of the kinds of projects that we're working on in my research program in this area. Teresa Cheng is going to be talking later today about fermented phenolic-containing feeds, basically using the microbial fermentation that takes place within a fermented feed to not only produce a probiotic effect, but also these fermented phenolic compounds may have some antimicrobial activities. Emmanuelle Goes, my PhD student, has a number of different projects, and she'll be presenting two of them. The first one involves glucosamine-derived caramels. Now, this is not specifically in the antibiotic alternative space, but glucosamines are purported to have some beneficial effects on soft tissue or cartilage and joint health in particular. And so the glucosamine-derived caramels, which are products from glucosamine, may have a greater impact on joint health. And so really this is looking at the impact on bacterial chondronecrosis and osteomyelitis. And there are some potential impacts on gut health as well. So mainly she's looking at this from a joint health standpoint, but there's also potential gut health implications as well. And she'll be talking about this a little bit later today. Emmanuelle is also looking at shellfish chitin. So these are oligosaccharides derived from the exoskeleton of shellfish. Again, these derivatives, these carbohydrate derivatives, may have a beneficial effect in terms of reducing the risk of a necrotic enteritis infection. And she'll be speaking on that project on Wednesday morning. One of the projects Emmanuelle is working on that she won't be presenting today is looking at punicic acid. Punicic acid is a conjugated linolenic acid found at high levels in pomegranate seed oil. And again, there's indications that this particular fatty acid has some antimicrobial characteristics that may be beneficial in terms of protecting birds from necrotic enteritis. I have a couple of upcoming projects in this research field as well. I'm working with a company out of the UK called Arden Biotechnology, assessing bacteriophages to protect broiler chickens against Clostridium perfringens. And this is also part of a platform technology looking at the ability to trace products and trace the effects of additives economically throughout the production cycle, all the way from broiler production through the finished product ending up in grocery stores and maintaining traceability. I have a collaboration with a colleague at Biological Sciences at the University of Alberta looking at Saccharomyces boulardii to inhibit Clostridium perfringens. And so these are all working in that antibiotic alternative space. Edward Fan is a PhD candidate, and he'll be presenting on Wednesday on his work on commercial broiler barn sanitation methods and the subsequent risk of human and poultry pathogens in broiler flocks. And so really looking at the impact of different sanitation methods on carryover of both beneficial and potentially pathogenic bacteria from one flock to the next as it's influenced by the cleaning, barn cleaning method. So I haven't presented any data. My students will be doing that. But as I've been working in this field, I've come to realize that there are a number of different products that show promise using different mechanisms in how they may be part of the solution to replacing antibiotic growth motors. Now, of course, there are a lot of products that don't work. And so the trick is really to understand how individual products work, the mechanisms by which they work, and then how we might look at multiple strategies used at the same time in order to replace that overall function of antibiotic growth motors. And so really, there's not likely to be a single silver bullet. It's likely going to be a multifactorial approach. So we don't necessarily expect to have a silver bullet, but maybe lots of silver BBs will be effective. We've also realized that we need to tweak our natural subclinical necrotic enteritis challenge model. We would like it to be slightly more pathogenic. We often see fairly subtle effects in terms of performance. And so we'd like to be a little bit more pathogenic so that we can see some more significant differences between our positive control containing antibiotics and coccidiostats and our negative control containing no antibiotics, no coccidiostats, so that we can actually evaluate whether our test products have a protective effect or not. I also am working fairly extensively in laying hen nutrition, particularly looking at bone and eggshell quality. And this is becoming more and more important, particularly as birds are producing more and more eggs and around the world are being kept for longer and longer times. I've had two former students that have graduated with their PhDs and are now working in academia and industry. looking at phytase use in laying hen diets, particularly over long-term trials. And we've also recently completed a phytase and carbohydrates combination use trial in laying hens as well. And really what's one of the important things that's come out of this research is that we need to reevaluate the calcium and available phosphorus requirements or provision for commercial laying hens. So in this experiment, it was a phytase experiment, and our positive control diet contained 0.43 or 0.4, depending on the age, available phosphorus. And we dropped that down to 0.28 and 0.25. So that's a pretty substantial reduction relative to the management guides. And you can see that there was absolutely no effect on performance. And this was a long-term experiment. We started feeding at 19 weeks of age, and we finished the experiment at 74 weeks of age. Now, when we add phytase at 300, 600, or 1200 phytase units per kilogram of feed to the negative control diet, we saw absolutely no effect on egg production, either weekly or cumulative. And so this indicates that our negative control diet was not really deficient. And so there's nothing for the phytase, for the phosphorus that was liberated by the phytase to do physiologically. So we have also tweaked our approach a little bit. In this experiment, our negative control 1 diet was dropped all the way down to 0.16% available phosphorus, and our negative control 2 diet, we basically took out all the inorganic phosphorus supplementation, and that resulted in a diet with 0.12% available phosphorus. We fed these diets from 68 to 78 weeks of age, and we can see that the negative control 1 diet, there was no negative effect on egg production. There was, however, with the negative control 2 diet. Now, when we add phytase to the negative control 1 diet, there was nothing for the liberated phosphorus to do because the available phosphorus requirements were already being met. However, when we added phytase to the negative control 2 diet, this severely deficient diet, we saw a return to performance that we would expect. And so this is really showing that phytase needs to be the available phosphorus liberated from phytate by the phytase needs to be able to be used by the bird in order for the phytase to have an effect. And so we really would like to investigate what the actual available phosphorus requirements are for laying hens. And there's evidence that excess available phosphorus in the diet can actually have a negative impact on shell quality. So particularly with longer cycles, this is important. Nella Batras did some work in this space looking at calcium and phosphitin. Phosphitin is an egg protein that's highly phosphorylated, and it may increase calcium and phosphorus availability. And so in this study, she's not presenting it here at this forum, but in this study, over 4 weeks from 90 to 94 weeks of age, reducing calcium by 25% in the diet had no significant effect. And so it was difficult to assess whether or not the phosphitin was effective. But what it shows is that we're probably also feeding too high a level of calcium, and that can have negative impacts on the effect of phytase. It can have negative impact on the digestibility of phosphorus as well. Finally, in our laying hen research, we also looked at the effect of hen housing on egg nutrient composition. And so these diets were fed by the same feed company and very similar diets. And so we found that housing of laying hens, whether it's conventional cages or free run or free range, basically had no effect on the nutrient composition of eggs. So our take-home messages from our laying hen research is that laying hens actually have much lower available phosphorus and calcium requirements than are typically fed. And if we want to use phytase effectively, we need to keep that in mind. Laying hens are capable of sustained egg production well beyond the current standard age of depopulation in Canada, and laying hen housing systems do not affect nutrient composition of table eggs. I mentioned Matt Orshak and the work that he is going to be doing. We're looking at fava beans as a locally sourced protein ingredient to reduce the carbon footprint of poultry feeds. And so we're just lining up the last bit of funding for that, and we hope to start that in the fall. So thank you very much for your attention, and I'll be happy to take any questions that you might have.